I am choosing to start with a little bit of basic stuff. It don't take a lot of time. I think it is good to start here. And the very first item, I think some of you may have even heard me say something like this before. Seismic design, in its very essence, is an exercise in trade-off between strength and inelastic deformability. Inelastic deformability, in a very general sense, is the ability of a structure to continue to carry full factor gravity loads as it deforms beyond the stage of elastic response. Elastic response means we the earthquake passes, we get our structure back intact. There are no residual displacements and therefore no damage associated with elastic response. Now, inelastic deformability that we are talking about comes from proper detailing of the structural members and the joints. So in seismic design, the higher inelastic deformability we have, because our detailing is fancy, the lower level of strength we should be allowed to be designed for. The lower the inelastic deformability, because our detailing is relatively poor, the higher the need for design strength. So this is something that absolutely must be always understood. In the IBC, Chapter 16 sets the design force level, the strength that we are going to provide to a code design structure. Detailing rules, which will give us inelastic deformability, various degrees of inelastic deformability, are given in the materials chapters of the code. 19 for concrete, 21 for masonry, 22 for steel, 23 for wood. The materials chapters of the code by now basically simply reference material standards. Chapter 19 on concrete, for instance, adopts by reference ACI 318, and that's where the detailing requirements are to be found. In our codes and standards, for quite some time now, we have had three distinctly defined levels of detailing: ordinary, intermediate, and special. Okay. So chapter 16 gives us the design force level. Chapter 19, or more specifically ACI 318, gives us three distinct detailing levels for concrete: ordinary, intermediate, and special. And then the R value, which is also in chapter 16, provides the link between the design force level and the detailing rules in the materials chapter. As you know, the higher the R, the lower the design force level, and the higher the need for inelastic deformability or very careful detailing. The lower the R, the higher the design force level, the lower the need for inelastic deformability or the need for careful or special detailing. Okay, so this is the overall setup. Now, as you know, every structure to be designed by the code is assigned to one of five seismic, actually six seismic design categories, A through F. A is essentially non-seismic, so a structure assigned to design category A does not even have to be seismically designed. It is kind of out of the scope of our discussion today. If a structure is assigned to design category B, for in the design of that structure, we will be allowed unrestricted trade-off between strength and inelastic deformability. We can provide ordinary detailing designed for a high force level. We can provide intermediate detailing designed for a somewhat lower force level, or we can provide special detailing and designed for very low force level.